The Earth has been a much warmer place than it is now. We are all very concerned about global warming and its rapid effects that are taking place in our modern day society. But during geological time, the Earth has been a lot hotter. Can you imagine an Earth that was 15 degrees Celsius warmer, and even places like the poles ended up having relatively balmy, warm days? Whereas now in the modern day environment, the average temperature in the South Pole is about negative 57 degrees Celsius. So a completely different Earth. So these time periods when the Earth became warm, what drove that? Well, we had increases in volcanic activity, which produced more CO2 in the atmosphere. We also had changes in the amount of radiation that were hitting the Earth from the sun. So collectively, there were multiple things that happened, but in the end, it made a dramatic increase in the temperature of the average temperature of the planet. And as a result of it, all the water that's stored during cooler planet times in the ice, all that water left the ice, melted the ice sheets, and went back into the oceans. So it raised the oceans during these warm greenhouse time periods a remarkable 250 to 300 meters above modern day sea level. Can you imagine that? That means that in the United States, a place like New York City, which is now right at sea level, it would be 300 meters below sea level. And that means that places that are very cold now in the United States, places like Minneapolis, Minnesota, they'd actually be the beaches. It'd be the place where the warm waters would lap up against the edge of the continent. And in fact, if you ever tour through Minneapolis, Minnesota, you can see the examples of ancient beaches from these time periods that are fossilized and make the foundations under which all the buildings are built upon. So the Earth has responded to these warm, what we call greenhouse planet times, where the CO2 builds up, the Earth heats up, the ice sheets melt, sea level rises. And that was the perfect combination, the perfect recipe in the Pennsylvanian time period to allow plants to rapidly evolve and then proliferate, have very large volumes of biomass grow all over the planet because of the warmth and because of the increase of the CO2. One of the products of that is that with the rapid development and production of plant material, that plant material, once it's formed, it has to go somewhere. So it fell in place in marshes and deltas and what have you. It accumulated, those areas subsided, it became compressed and became a hard rock that we call coal. And we depend on these Pennsylvanian coals for a major part of global energy needs. So therefore, we have an Earth environment where evolutionary biology is responding to it by producing plants at a remarkable level and then having those plants be fossilized through time and produce the coals. So that's the Pennsylvanian greenhouse. There's one more major greenhouse we want to compare and contrast to here, and that is the greenhouse that took place in the Cretaceous time period in the latter third of the Mesozoic. So in that time period, we'd already had plants well established, but in the Cretaceous, plants even went further, and flowering plants evolved very rapidly and very quickly, partially in response to, again, the high CO2, the high sea levels, and the warm average temperatures of the planet. But even more remarkably at that time, we had the proliferation of the dinosaurs. So as the planet warmed, remember the dinosaurs are ectothermic. They can't create much of their own body temperature, so they have to depend on receiving heat from the environment. So if you start having an environment that's overall much warmer, then the dinosaurs and other cold-blooded organisms are going to do extremely well. So the rise of the dinosaurs and their dominance in the Cretaceous was partially because it was a greenhouse Earth of high sea levels and very warm time periods. So we've seen the Earth go through these traumatic time periods of very warm planet, no ice sheets, and high sea level. And evolutionary biology has responded in kind in the Pennsylvanian with the proliferation of the plants and in the Cretaceous with the proliferation of the dinosaurs.